Okay, good evening, everybody. This is one of the last ones that last flip lessons I'll probably be making for you guys, and probably one of the last ones I'll be making for quite a while, actually. Same drill as before. Take down all the notes you need. Write down plenty of fifth color. Make sure you're using multiple colors. And pause as needed, rewind if I'm going too fast or whatever. But hopefully these will be one of your last bit of really, really high quality notes for this year, and next year you'll be continue to do high quality notes. Okay, so what we're going to talk about today is graphing absolute value equations. So you see that I have two different, I might as well get this over with right now. I found a very cool new little trick here with the this app. So I can use lightsabers for my pointers. So I can go, oh, look at that over there. And the ridiculously cool thing is I can do this. Ha! Ching, 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 ching. And just in case you thought that was it, bam, I got three going on at once. So prepare to be way overstimulated because I'm sure that I'm going to use this like ridiculous. All right. So the first thing we're going to have, so we have two different equations here. We got this one here, which is y is the absolute equals the absolute value of x minus 2 plus 3, and we have y equals the absolute value of negative absolute value of x minus 2 plus 3. So I just rewrote them into two columns, and you're going to see that that's how we're going to be doing all of these notes are in two columns. Okay, so the first thing that we want to notice or we want to look for is it a max or a min? Okay, and we talked about this a little bit last week about what a max and a min is. It's going to be the exact same as we did that we were looking at with parabolas. For parabolas, if we had negative x squared, so if we had for parabolas, if we have x squared equals a min and negative x squared equals a max. Well, we're looking at the same thing here. So if I have a absolute value equation and the absolute value is positive in front here, that's positive, then that absolute value is going to be going in this direction. It's going to be going like an actual V, which means that I have a lowest point and an infinite number of high points, which means this is a minimum. Okay, so a positive absolute value equals a minimum. And then of course we look over here and I see that I have a negative absolute value, a negative out front. So that means that it would be going in that direction, which means that I have a top but no bottom, which means a negative absolute value equals a maximum. And what we mean by that is that there's a maximum value that it can be, but there's no minimum value it can be. It's a maximum value only. So we call that a maximum. And the very first thing you want to figure out is it a minimum or is it a maximum? Okay, that's the first step. Okay, now we go to the next step. And for the next step, you see we got the same two equations. We're going to find the x value of the vertex. And to find the x value of the vertex, what you do is you let the absolute value equal 0. And you ignore everything else. So I'm going to ignore this right here. I'm going to ignore the plus 3. I'm just going to make this part equal to 0. So I'm going to write it like this. 0 equals the x minus 2. And then I'm going to solve for x. So add 2 to both sides, add 2 to both sides. So x is equal to 2. So for the vertex, this vertex, the absolute value is the x part of the absolute value is 2. And we don't know the y yet, so I'm just going to put in the y like that. But we know that the x value is going to be 2 for the vertex. Okay, and so for the other one, I'm going to do a very similar thing. I'm going to let the absolute value equals 0, and I'm going to ignore everything on the outside. So I'm going to ignore this and this. So notice that I got rid of the lightsabers. That was even a little bit annoying for me. So I'm going to say 0 is equal to x minus 2. I don't change the sign or anything. It doesn't become positive because I got rid of it. I just do it like that. So I'm going to add 2 to both sides, add 2 to both sides. So we get x is equal to 2. And you'll notice that the vertex here is got the same x value. And that makes sense because the only thing that's going to be different between this graph and this graph is the direction. The vertex is actually going to be the same. It's just this graph is going to be going up and this graph's going to be going down. So we should have the same vertex down here. Now, this 2 is also the line of symmetry, right? So we also just found the line of symmetry, which is going to help us later. Okay, after we got our vertex, the x value of the vertex, we need to find the y value of the vertex. And to find the y value of the vertex, that is, let's see, let me get a color here. The constant. Normally the constant is our our y-intercept. In this case, it's the y value of the vertex. So it's super easy to find the y value. From our x we had before, it was 2. And for our constant, what we do is we look at this right here. Whatever thing we're adding at the end of our absolute value, that is going to be my y value of the vertex. So the y equals 3. So I put a 3 in there, and that's my vertex, 2, 3. For this one, it's the exact same thing. It's the constant. So the y is equal to 3. And again, I don't worry about that negative in front. That has no effect on this. That negative is affecting the direction of this absolute value. It's not directing that. So then the vertex is 2 from before and 3 from this one. So 2, 3 is the vertex. All right, take a look at the next thing. So now we're ready to graph. And we're going to go ahead and graph our vertex. So if I recall from a second ago, for both of these, the vertex was 2, 3. So I'm going to come here and go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 2, 3 right there is my vertex. Now, to find the, now this one here is going to be going up, right? It's going to be going up. So to find where this line goes, it's based on y equals mx plus b. So I'm going to use the slope of what's inside my absolute value. So the slope for inside my absolute value is, let me, y equals x minus 2. So slope would be equal to 1 for this. So that means I'm going to rise 1, run 1 right there. And as soon as I find a point, I can draw my line. It's going to go off in the same direction forever. And then, because this is my line of symmetry right here, I know that if that went rise 1, run 1, then there's going to be rise 1 and then 1 in the opposite direction. So that's my second line right there. And there's my graph. I use the vertex and the slope of the graph. And then I know it's going up because this is positive. If it were negative like this one, it's going to be going down. We're going to do that one right now. So to do that one, I'm going to start by graphing my vertex. So again, that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Should have put those in there. So 2, 3 is my vertex. Again, this is my line of symmetry. And then I'm still going to use the same slope, except because this one is going down because of this negative right here, then from this point I've got to go down first. So I'm going to go down 1 and right 1, and there's my graph. That should be right over that 2. So it goes like that. And then my line of symmetry, down 1 and right 1 that direction, and there's my graph. So just like that. So there's my graph. It's pretty simple to do. You find the vertex, and then use the slope to graph the next 2 points and line of symmetry. It's pretty simple. Let's take a look at one from the beginning. Okay, so here we go. So I'm going to start by finding my max or min. So looking at this one is going to be a min because the absolute value is positive, which means it's going to be going in that direction. Okay? Now to find the x value of my vertex. So the x of the vertex, whoops, I want to do that in a different color. X of the vertex, I'm going to have 0 equal x plus 2, subtract 2 from both sides, so x is equal to negative 2. So the x value is negative 2, and I don't know the y. To find the y of vertex, that is the constant. And this constant equals 0. So y is equal to 0, so I plug this in. So my vertex is going to be equals negative 2, 0. Alright, so now I can plot my vertex. So I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, negative 5. So my vertex is going to be at negative 2, 0, which is right there. And now, to find the lines, I use the slope. And so the slope for y equals x plus 2, m is equal to 1. And since this is going up, it's a minimum, so I'm going to rise 1, run 1, so right there is my second point, and my line goes like that. And then if we recall, this is my line of symmetry, so that means if there's a point here, if there's a point right here, then there's a point on the opposite side over there, and so I'm going to put my point on the opposite side right there, and there's my line that goes like that. Okay, so there's my graph. Alright, let's take a look at one more. Okay, so the same exact things. I'm going to look and see if it's a max or a min. This is going to be a max because the absolute value is negative. My x value of the vertex, so I say 0 equals x, so that means it's going to be 0. So that means here it's going to be 0y for my vertex. The y value of my vertex is the constant, which equals negative 3. And then now my vertex is the point 0, negative 3. I can now plot that. So I go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 5, negative 5, 5, and 5. So now I can plot the vertex at 0, negative 3, which is right there. And this is my line of symmetry, so my x-axis is my line of symmetry. Excuse me, my y-axis, my line of symmetry. And now I can use the slope here. Okay, now, so to find the slope of this one, it's a little bit different because we do have a coefficient other than 1 outside here. So for this one, my slope is going to be y equals 2x. Okay, so this 2 here is this 2 here. So now I'm going to be going 2, rise or fall 2, and then 1. So because this is a max, that means I need to be going down first. So because there's a top here, the top can't be higher than that point there. So I'm going to go down 2, 1, 2, and run 1. Right there, and there's my point. It goes like that. And then my other point is going to be across the line of symmetry. So that's going to be the point right there, and it's going to go like that. So there's my graph. Okay, so that's how you graph absolute values. We use a lot of the same stuff we used before. A little bit of understanding about the max and the min part, and understanding where the different parts come from in the equation, but a lot of it is the same as what we were doing for quadratics. Okay, that's it. That's the second to last notes that you were hoping for this year, and pretty soon we'll get the actual notes you're looking for. All right, I will see you guys tomorrow.